Good morning, viewer. Welcome to our Active English viewers. Here's the breaking and amazing news for our viewer. For the first time, a team of US researchers has used sensors containing highly excited Rydberg atoms to detect the signals from an ordinary handheld radio. Yeah, through a careful approach to demodulating the incoming signals, Noah Schulzberger and colleagues at the National Institute of Standards and Technology were able to recover audio encoded in multiple public radio channels, while a promising implication for everyday uses in consumer electronics. The research has been published in Physical Review Applied. Viewers, in a Rydberg atom, a single electron is excited to an extremely high energy level, pushing it from its host atom's nucleus. Yeah, for the same for a distance, and from a distance, these atoms resemble a single electron obtaining and orbiting a positively charged ion. When any atom is exposed to an external electric field, the positions of its electrons' energy levels shift through a process called the stack effect. So, yet in a Rydberg atom, the shift becomes far more pronounced, causing particularly striking changes in the spectral patterns produced when the atom is probed by a laser. So, this effect ultimately means that Rydberg atoms are ideally suited as electric field sensors, a possibility the Rydberg sensor project's group leader Christopher Holloway began to explore in 2009. So, embarking on this project, Holloway's team soon realized that the possibilities were far more wide-ranging than they first anticipated. One of the more intriguing applications is atom-based receivers, where these Rydberg atom sensors act like an antenna to detect the signal and perform the demodulations and down conversion automatically, Holloway describes. In principle, these Rydberg receivers could eliminate a lot of the front end devices and electronics when compared to the conventional receiver. So far, however, the possibilities of these atomic sensors have largely been explored within the confines of the lab, leaving the full scope of their potential real world applications largely unexplored. Beyond this exclusive report.